when we consider the right side to have all the positive coordinates, then the opposite of that positive will be the negative coordinates, or the opposite side will contain all the negative coordinates. So currently we have positive x that contains the negative number. So the opposite x, which is the negative x, will obviously contain a positive 3, just like this. That's why we see when we apply -3 inside that absolute value theorem or that absolute value notation, we see that we get an answer of positive 3. So this explains why we get an answer of positive 3 when we refer to the absolute value of -3. Now we will get more idea about how this thing works when we start discussing about the rules. There are 10 rules that we must remember, and there is one another point about how can we determine the distance between one x from the other x. Just like if we consider this to be x1 and we consider this to be x2, then we have a formula to determine how many or what's the distance between these 2 points. We are referring to 2 points right now, and x1 contains -3 and x2 contains +3, and we now know why that applying the absolute value theorem on the -3 gives us the exact opposite number, which is +3. So let's move on to the rules now. The first rule that we are going to discuss about is the first rule that we are going to discuss about is as I call it, rule 1. Let's have a look, which will be actually similar to the example that we have seen right now. So let's move on to a new page, and let's say this is rule 1. So under rule 1, it states using this notation that the absolute value of the negative x, or if we apply the absolute value of negative x, then it will always equal to the absolute value of positive x. So how do we determine that? So there are 3 steps that we are going to take at first, and likewise for other rules we're going to see how the steps will work. So let me draw a number line first, and let me assign the origin, which is 0, and let's say that the and obviously we will say that the right hand side is the positive side, or it contains all the positive coordinates, and we're going to say that x is moving towards the positive side, or x also includes 0. Now one thing that we must remember, I'm going to explain why I have included this dot along with this arrow in the next part when we discuss about the absolute value and inequality, or how to actually look at the notation that's used to determine the limits of a domain. So you don't have to get worried right now. So let's consider that currently x contains the value of 0. So when x contains the value of 0, if we use the notation which is the absolute value of negative x, and we apply 0 in terms of x, then we get something like this. So 0 can't be negative, 0 can't be positive either. So 0 is a number by itself which does not contain any sort of symbol. So we can likewise say 0, and this gives us a hint of what's coming next. So just like we have said that the absolute value of negative x renders something similar to x, or when we apply 0 to the absolute value of negative x, or we replace this variable x with a constant number or a constant coordinate which is 0, and we see that 0 does not have any sort of symbol, we can remove that symbol and we get something like the absolute value of 0. So this can be equals to, or we can also write the absolute value of x, because currently x does not have any sort of symbol. So, uh, so this proves that the minus, when we apply the absolute value theorem on the negative x, we can also write that it can be equals to, or it can also be written as the absolute value of x. Now this is one form or one step. The next step that we're going to look is when, or let me first actually draw the number line for you. Let me erase this off. Okay, so this is the number line. We must assign the origin, which is 0, and we must say conventionally that the right hand side contains all the positive uh, coordinates. Now we are now going to say, okay, I made a small mistake, which is um, sorry for the mistake, that I shouldn't have included this. I should have written something like x contains 0, or x is currently stationed at 0 right now, or at this moment x is stationed at 0 for the first step. So for the next step will be, this will apply something like this, which means that x is now either 0 or x is more than 0. Or we can simply say, rather than taking all this together, then we can say that x is moving along the line of the 0. So let me take out that dot, that's not necessary.